total number of proposals was 144. The acceptance rate was 56 accepted divided by 144 total, equaling 0.39, or 39%. Reasons for the lower percentage included the rejection of proposals to change fixture wire to luminaire wires several times, and the rejection of companion proposals to 250.32 B2. While the overall acceptance rate of 39% may not have met expectations, it is important to note that specific proposals encountered resistance due to the following factors. The proposals to change fixture wire to luminaire wire were likely rejected because they involved a significant departure from established industry practices and safety standards. Companion proposals are typically intended to provide additional clarification or support for a main proposal. However, in this case, the companion proposals to 250.32 B2 may not have been compelling enough on their own to gain acceptance. Despite these challenges, the submission of 144 proposals and the acceptance of 56 of them is a testament to dedication and expertise in the field. Looking at fixture wire versus luminaire wire, it's essential to understand the nuances that might have led to the rejection of these proposals. Fixture wire, as defined by the National Electrical Code, is typically used for internal wiring of luminaires and appliances. It's designed to withstand the heat generated within these devices. Luminaire wire, on the other hand, is a broader term that can encompass various types of wires used in lighting fixtures. The code distinguishes between these types of wires based on their specific applications and performance characteristics. The proposals to change fixture wire to luminaire wire likely aim to broaden the scope of acceptable wiring methods within luminaires. However, such changes could have implications for safety and performance. For example, fixture wire is often required to have a higher temperature rating than general luminaire wire due to its proximity to heat-generating components. The rejection of these proposals suggests that the proposed changes did not adequately address the potential risks associated with using a broader range of luminaire wires in these applications. The decision-making process for code changes involves careful consideration of safety, reliability, and industry practices. Code-making panels consist of experts from various fields, including electrical engineers, contractors, inspectors, and manufacturers. These panels evaluate proposals based on technical merit, supporting data, and potential impact on safety. The rejection of a proposal doesn't necessarily mean it was without merit, but rather that it didn't meet the stringent criteria for adoption into the code. In the case of the companion proposals to 250.32 B2, it's important to understand the context of this code section. 250.32 B2 addresses the grounding requirements for separately derived systems in buildings or structures. Separately derived systems are electrical systems that receive power from a source other than the main service, such as generators or transformers. These systems require specific grounding methods to ensure safety and prevent electrical shock hazards. The companion proposals to 250.32 B2 likely aim to clarify or expand upon the existing grounding requirements for separately derived systems. However, their rejection suggests that the proposed changes were either unnecessary or didn't adequately address the intended purpose. It's possible that the existing code language was deemed sufficient to cover the intended application, or that the proposed changes introduced unintended consequences. The code-making process often involves multiple iterations and revisions before a proposal is ultimately accepted or rejected. Proposals may be modified or combined with other proposals to address specific concerns or improve clarity. The rejection of the companion proposals to 250.32 B2 highlights the importance of thoroughly researching and understanding the existing code requirements before submitting a proposal for change. It's also crucial to provide clear and concise justification for the proposed changes, along with supporting data or analysis. The process of submitting and evaluating code change proposals is a critical aspect of maintaining the safety and reliability of electrical systems. It allows for continuous improvement and adaptation to new technologies and industry practices. While the rejection of proposals can be discouraging, it's important to view it as an opportunity to learn and refine one's understanding of the code. By carefully analyzing the reasons for rejection and incorporating feedback from the code-making panels, it's possible to improve the chances of success in future submissions. Additionally, it's worth noting that the code-making process is a collaborative effort. Engaging with other industry professionals, attending code-making meetings, and participating in online forums can provide valuable insights and perspectives. By working together, it's possible to ensure that the National Electrical Code remains a relevant and effective tool for promoting electrical safety. When evaluating proposals related to wiring methods such as the fixture wire versus luminaire wire issue, several factors come into play. Firstly, the ampacity of the conductors must be considered. Ampacity refers to the current carrying capacity of a conductor, and it's determined by the conductor size, material, and insulation type. The National Electrical Code provides tables that specify the allowable ampacities for various types of conductors under different conditions. Any proposed changes to wiring methods must ensure that the conductors are adequately sized to carry the intended current without overheating. Secondly, the voltage drop in the conductors must be taken into account. Voltage drop occurs when electrical current flows through a conductor, and it's caused by the conductor's resistance. Excessive voltage drop can lead to reduced performance of electrical equipment and increased energy consumption. The National Electrical Code recommends limiting voltage drop to a certain percentage of the supply voltage, typically 3% for branch circuits and 5% for feeders. Proposed changes to wiring methods must ensure that voltage drop remains within acceptable limits. Thirdly, the environmental conditions in which the conductors will be installed must be considered. Factors such as temperature, moisture, and exposure to chemicals can affect the performance and lifespan of conductors. The National Electrical Code specifies different types of insulation for conductors based on their intended use in various environments. For example, conductors installed in wet locations must have moisture-resistant insulation. Proposed changes to wiring methods must ensure that the conductors are suitable for the environmental conditions in which they will be installed. Fourthly, the mechanical protection of the conductors must be considered. Conductors must be protected from physical damage, such as abrasion, impact, and crushing. The National Electrical Code specifies various methods for providing mechanical protection, such as using conduit, cable trays, or raceways. Proposed changes to wiring methods must ensure that the conductors are adequately protected from physical damage. Fifthly, the grounding and bonding of the electrical system must be considered. Grounding and bonding are essential for preventing electrical shock hazards and ensuring the proper operation of electrical equipment. The National Electrical Code specifies detailed requirements for grounding and bonding, including the size and type of grounding conductors, the methods for connecting grounding electrodes, and the bonding of metallic enclosures. Proposed changes to wiring methods must comply with these grounding and bonding requirements. In the specific case of the proposals to change fixture wire to luminaire wire, it's possible that the proposed changes didn't adequately address one or more of these factors. For example, the proposed changes may have allowed the use of luminaire wire with a lower temperature rating than required for the intended application, or they may have compromised the mechanical protection of the conductors. The code-making panels would have carefully evaluated these factors before making a decision on the proposals. When considering companion proposals to 250.32b2, it's important to understand the purpose and intent of this code section. 250.32b2 addresses the grounding electrode system requirements for separately derived systems. A separately derived system is an electrical system that receives its power from a source other than the main service, such as a generator, transformer, or uninterruptible power supply. These systems require a grounding electrode system to provide a low impedance path for fault current and to minimize the risk of electrical shock. 250.32b2 specifies the acceptable methods for establishing a grounding electrode system for separately derived systems. These methods include connecting to a metal water pipe, a metal frame of the building, or a ground ring. The code also allows for the use of other grounding electrodes, such as ground rods or ground plates, if certain conditions are met. The companion proposals to 250.32b2 likely aim to clarify or expand upon the existing requirements for grounding electrode systems for separately derived systems. However, their rejection suggests that the proposed changes were either unnecessary or didn't adequately address the intended purpose. It's possible that the existing code language was deemed sufficient to cover the intended application, or that the proposed changes introduced unintended consequences. One potential reason for the rejection of the companion proposals is that they may have conflicted with other requirements in the National Electrical Code. The code is a complex and interconnected document, and changes to one section can have unintended consequences on other sections. The code-making panels must carefully consider the potential impact of any proposed changes on the entire code before making a decision. Another potential reason for the rejection of the companion proposals is that they may have lacked sufficient technical justification. The code-making panels require strong evidence and data to support any proposed changes to the code. This evidence may include test reports, engineering analysis, or field experience. If the companion proposals didn't provide sufficient technical justification, the code-making panels may have rejected them. It's also important to note that the code-making process is a consensus-based process. The code-making panels consist of representatives from various stakeholder groups, including electrical contractors, engineers, inspectors, manufacturers, and utilities. These representatives must reach a consensus on any proposed changes to the code. If there is significant opposition to a proposal from one or more stakeholder groups, the proposal is unlikely to be adopted. In summary, the rejection of the companion proposals to 250.32b2 could have been due to a variety of factors, including a lack of necessity, conflict with other code requirements, insufficient technical justification, or lack of consensus among the code-making panel members. The process of developing and revising the National Electrical Code is a rigorous and thorough process designed to ensure the safety and reliability of electrical systems. The code-making panels carefully consider all proposed changes to the code, and they only adopt changes that are supported by strong evidence and that are in the best interests of the public. When analyzing the proposals related to fixture wire and luminaire wire, it's crucial to understand the specific types of conductors involved in their intended applications. Fixture wire is a type of insulated conductor specifically designed for use in lighting fixtures and similar appliances. It's typically smaller in size than building wire and has a higher temperature rating to withstand the heat generated by the fixture. The National Electrical Code specifies different types of fixture wire based on their insulation material and temperature rating. Some common types of fixture wire include type TFN, type TFFN, and type SF. Type TFN is a thermoplastic fixture wire with a nylon jacket and a temperature rating of 90 degrees Celsius. Type TFFN is a thermoplastic fixture wire with a nylon jacket and a flexible stranding, also with a temperature rating of 90 degrees Celsius. Type SF is a silicone rubber fixture wire with a fiberglass braid and a temperature rating of 200 degrees Celsius. Luminaire wire, on the other hand, is a more general term that can refer to any type of insulated conductor used in lighting fixtures. It may include fixture wire, but it can also include other types of building wire, such as type THHN or type THWN. The National Electrical Code doesn't have a specific definition for luminaire wire, but it's commonly used in the industry to refer to conductors used in lighting fixtures that don't meet the specific requirements for fixture wire. The proposals to change fixture wire to luminaire wire likely aim to allow the use of a wider range of conductors in lighting fixtures. This could potentially reduce costs and increase flexibility in fixture design and installation. However, the code-making panels would have carefully considered the potential safety implications of such a change. One concern is that using a lower temperature-rated conductor in a lighting fixture could lead to overheating and fire. Fixture wire is specifically designed to withstand the high temperatures that can occur inside lighting fixtures, while other types of building wire may not be. Another concern is that using a smaller sized conductor could lead to excessive voltage drop and reduce performance of the lighting fixture. Fixture wire is typically sized to minimize voltage drop, while other types of building wire may not be. The code-making panels would have evaluated these potential safety and performance issues before making a decision on the proposals. They would have also considered the potential impact on the overall reliability and lifespan of lighting fixtures. In addition to the specific types of conductors involved, the code-making panels would have also considered the installation methods and environmental conditions in which the conductors would be used. The National Electrical Code specifies detailed requirements for the installation of conductors, including the use of raceways, cable trays, and other protective measures. These requirements are designed to protect conductors from physical damage and to prevent electrical hazards. The code-making panels would have considered whether the proposed changes to allow the use of luminaire wire would compromise these installation requirements. They would have also considered the potential impact on the overall safety and reliability of electrical systems. In summary, the proposals to change fixture wire to luminaire wire were likely rejected because they could have compromised the safety, performance, and reliability of lighting fixtures. The code-making panels carefully considered the potential implications of such a change and determined that it was not in the best interests of the public. The National Electrical Code is a constantly evolving document, and the code-making process is designed to ensure that it remains up to date with the latest technologies and industry practices. The rejection of these proposals highlights the importance of carefully considering the potential safety and performance implications of any proposed changes to the code.